Hi, my name is Shahnawaz. We begin this lecture with the following lemma. So, if we have to spaces say x and y, so let x and y be topological spaces, and suppose P is a continuous map from x to y. And let us choose some point, say x naught in x. So this is 80 point. Then this continuous map P induces a homomorphism. So then P induces a homomorphism. Say P star from the fundamental group of x based at x naught to the fundamental group of y based at um, p of x naught. So let us prove this. So let us choose some homotopy class. So let f be the homotopy class in the fundamental group of x based at x naught. And then this f will be a loop based at x naught. So then this f is a map from the interval say 0 1 to x is a continuous map such that f of 0 is x naught, which is same as f of 1. Now we define this p star. So define this p star from pi 1 x x naught to pi 1 y p of x naught by so this p star takes, so this define this by, so p star takes the homotopy class f and it maps it to the homotopy class of p composite with f, p composite with f. So note that this homotopy class, I mean the map p composite with f, uh, is first of all continuous, and so note that this p composite with f is a map from the interval 0 1 to y. So since f is continuous, p is continuous, so the composition map is continuous. So this is continuous. And p composite with f of 0, which is same as P of x naught, which is same as P composite with f of 1. So that means this P composite f. So this P composite with f is a loop in Y based at f based at P of x naught. So that is the homotopy class of P of f. This is an element of pi 1 of y P of x naught. So that means this P star takes a homotopy class here, and it takes this class to the homotopy class in this pi 1 of ypx naught. Now first we'll show that this P star is a well-defined map. So moreover, uh, P star is well-defined. For if suppose the homotopy class of f is same as homotopy class of G, then we have to show that their P star images same as well. So if they are these two homotopy classes are same, that means this f and G are homotopic. So then f is homotopic to G, and hence there exists a homotopy, say H, between f and G. Now one can easily verify that. One can easily verify that uh, these composite maps P of f is composite with is homotopic to P composite G, where the homotopy P composite H. So uh, these two maps are homotopic via this homotopy. So one can easily prove this is a homotopy between these two maps. So hence the homotopy classes of these maps will be equal. That is P star of f is same as P star of homotopy class of G. So this proves that this P star is well defined. Now let us prove this is a homomorphism. So now one can note here the identity element in this group is, I mean, since this is a group, so it has an identity element which we denote by cx node. That means the path and the loop which stays all the time at x node, and the identity element in this group is c of px node, i.e. the path which stays all the time at p of x node. Now to prove this P star is a homomorphism, first we'll show that it preserves the identity element, i.e. it takes the identity element to the identity element. So note that C sub x naught is the identity element of this group pi1 x x naught. Now let us see what will happen when we take it as p star image. I mean the homotopy class, p star image of it is homotopy class. Now p star of the homotopy class of cx naught. So this is by definition, this is the homotopy class of p composed with c sub x naught. Now p composed with c sub x naught, so if we choose any point, say x in x, then p composed with c sub x naught of x will be p of, now c of x naught of x is x naught, so that is p of x naught. So that means this will be, this is for all x in x, we have this thing. That means this composition map is a map which stays all the time at x naught. So that means this is same as the homotopy class of c sub p of x naught, so which is the identity element of pi1 y of p of x naught, which is the identity element of pi1 of y p of x naught. Now let us prove this p star preserves the products. So finally, we prove that p star preserves the products of paths, sorry, the products of homotopy classes, product of homotopy classes, i.e. we have to prove this p star of the product of homotopy class of f and homotopy class of g. This is same as p star of the homotopy class of f product with p star of homotopy class of g. For all the classes f and g in pi1 x x naught. Now on the one hand, now on the one hand, p star of f product with g, this is same as p star of f dot g, which is same as the homotopy class of p composite with f dot g, where this f dot g is the path from interval 0 1 to x, given as it is f of 2s if 0 is less or equal to s is less or equal to half. It is g of 2s minus 1 if 1 is less or equal to, half is less or equal to s is less or equal to 1. So p of f dot g will be the path given as, so this will be p of f of 2s if 0 is less or equal to s is less or equal to half, and it is p of g of 2s minus 1 if half is less or equal to s is less or equal to 1. And on the other hand, and on the other hand uh, p star of f product with p star of g, so this is equal to the class of p of f product with class of p of g, which is by definition the class of p of f product with p of g, where 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 p of f product with p of g, this will be the map. So it is p of f of 2s. So first it will travel, uh, so first we will travel p of f in the interval 0 to half at twice the speed, and then we travel the path p of g in the next half interval, again at twice, I mean 2 times the speed. So one can look that this map and the map which we defined above, I mean this map, so they are the same maps, so hence their homotopy classes are going to be same. So hence the homotopy class of p composite with f dot g is same as the homotopy class of p composite with f product with p composite g, and this by definition this is, or this is by definition p star of f dot g. So this is by definition f dot g, and this is p star of f dot p star of g. So this proves the lemma that p star uh, is actually a homomorphism. So one should keep in mind that whenever we have a continuous map, say p from space x to y, then this p induces a homomorphism between their fundamental groups based at some point x naught. So one have to keep this in mind that we have to mention this x naught. So it depends on the point x naught. Now let us prove the consequence 2 of the homotopy lifting property. So consequence first we had done in the previous lecture. So we have consequence second. So it states that, so let P from X tilde to X be a covering map uh, let X naught tilde belongs to X tilde be a point. So now this P being continuous, so this will induce a homomorphism between the fundamental groups of X tilde and X based at X naught tilde and P of X naught tilde respectively. So then the homomorphism P star from the fundamental group of X tilde based at X naught tilde to fundamental group of X based at P of X naught tilde. So this is induced by P. So this morphism is actually injective. So we know if this P is just a continuous map, then this P star is a homomorphism. However, if P is covering, then this P star is injective as well. So then the homomorphism this induced by P is injective. Moreover, if gamma is a loop based at, say, based at P of X naught tilde such that this gamma is in the image of P star. I mean, this gamma belongs to the P star of pi 1 of X tilde X naught tilde. Then there exists a loop gamma tilde in X tilde such that this composition, I mean P composed with gamma tilde is gamma. Let us prove this. So first we'll prove that the induced homomorphism is injective. So we have the homomorphism, we have the homomorphism P star from pi 1 X tilde X naught tilde to pi 1 X to based at P of X naught tilde. So this homomorphism is induced by P, since this P is continuous. So this homomorphism is given as so this is, we have the homomorphism P star from these two groups, which is induced by P, given as this P star takes the homotopy class F and it maps it to the homotopy class of P composed with F. Now to prove it is injective, to prove this P star is injective, let P star of F is P star of G. So we are going to prove this homotopy cross of F is same as homotopy cross of G. So let us suppose that these two objects are equal for some homotopy classes F and G in the fundamental group of x tilde based at x naught tilde. So therefore, so that is the homotopy classes P composed with F is same as the homotopy class P composed with G, or the maps P composed with F is homotopic to P composed with G. Now, so we have these two maps. So actually they are the lefts of F and G, and we are given that these two maps, I mean the map P composed with F and P composed with G, they agree at the end points. So by the consequence, first F and G will be homotopic. So since P composed F and P composed G are the loops based at P of x naught tilde by consequence first. This consequence first is done in previous lecture, so this we have discussed in the last lecture. So by consequence first, the paths F and G are homotopic. Now if the paths F and G are homotopic, that means their homotopic classes will be equal. So this implies that the homotopy class of F and G are equal. So this proves P star is injective. Now let us prove the second part of the consequence, that is if gamma is a loop based at px node such that gamma is in the image of P star, then there is a loop gamma tilde in x node, sorry, x tilde. Actually we have missed something here. So this is a loop in x tilde, and this is the loop in x tilde based at x naught tilde, such that P composed with gamma tilde is gamma. Now let us prove the second part. So now let gamma be a loop based at be a loop in x based at P of x naught tilde. So the situation is like this: we have x tilde here, we had a point x naught, then we have the space x here and the point P of x naught. So this gamma is a loop in x based at this point. So this is gamma here. So that means we have the interval 0 1 here and the map gamma here. So this gamma is given such that this gamma is in P star of the fundamental group of x tilde based at x naught. So that means this gamma has a preimage under P star. So therefore there exists um, a loop. I mean there exists an element, say an element in this group, an element say sigma in pi 1 x tilde x naught tilde such that p of p star of this loop, I mean this homotopy class is the homotopy class of gamma, or p composite sigma is homotropic to gamma. So this follows by the subjectivity, sorry, this follows due to the reason that this gamma is in the image of p star. So this p composite with gamma is sigma is actually gamma tilde. So sigma is uh, a loop based at x naught. So this is sigma. So this is the map sigma here. Now we can invoke the the path lifting property here. So since we have this path gamma in x and this p is the covering, so we can lift this path in x tilde such that, so also by path lifting property, also by path lifting property, there exists a unique lift gamma tilde. Say there's a unit to say gamma tilde. Let us call this gamma tilde. So this is the path from 0 1 to x tilde. So this is the lift of gamma such that p composite with gamma tilde is gamma. Sorry. So this is gamma, and this gamma tilde starts at x naught tilde. So by the uniqueness, it follows that this gamma tilde has to be homotopic to sigma. So then gamma tilde of 1 will be sigma of 1, and this gamma tilde will be homotopic to sigma, but sigma of 1 is, so this is given to be x naught tilde because sigma is a loop based at x naught tilde. So that means now since uh, gamma tilde is homotropic to sigma and sigma is a loop based at x naught. This means this gamma tilde is a loop based at uh, x naught tilde. So this implies that gamma tilde is a loop based at um, x naught tilde. So, path lifting property assures us that this composition is, I mean, P composed with gamma tilde is gamma, but it does not assure us that this gamma tilde will be a loop. Now, gamma tilde will be a loop follows from the fact that this gamma tilde and this sigma, they are path homotopic. So, hence this gamma tilde will be a loop based at x naught tilde.